Hello programmers, welcome to the video. So today we'll be solving day 9 and it's a October Leetcode challenge. So let's jump into the problem. Okay. So question is saying the find the minimum amount of time to brew potions. Okay. You are given two integer arrays skills and mana of length nm respectively in a laboratory. Okay. So let me draw something. Okay. So we have a skill and we have a mana. Two of these arrays, its length n, its length m. Okay, great. Let's go ahead. In a laboratory, there is a laboratory. N wizards must brew m potions. Okay, so n is the also number of wizards. So number of wizards will be like this n, and this m is also like number of potions. Number of potions. Okay, now what they're saying ahead, m potions in order. Okay, we have to do some in ordering, some stuff, some kind of ordering. Each person has a mana capacity, mana of j. Okay, so these are like capacity. Mana is a capacity of a potion. So we can see that if potions has the size m, and like if we have a array of some element, let's say x y z, this is index 0, this is index 1, this is index 2. So this index are the positions, like 0th position, first position, second position, and its positions capabilities like x y z. Okay, like mana of 0, mana of 1, mana of 2, that's a kind of thing. And must pass through all the wizards sequentially to be brewed properly. Okay, so each portions, like let's take an example of this y portion. Okay, let me change the color green. So this y portion, each portion basically x then y then z, each portion must be gone through all these n wizards. There is n wizards. Okay, let's draw some of them, something like that. We have n wizards and each of the portions will go through each of the wizards. Okay, sequentially. Okay, so it will go one by one, like for first, then second, then third. Okay, sequentially to be brewed properly. The time taken by the ith wizard on the jth portion is time ij. Okay, so if this wizard is taking some time, so it's time of ith wizard in jth portion. So let's keep a pointer j here, and let's keep a portion of let's keep a I pointer is 0 to n, somewhere in between n minus 1, because we don't know how to point it on array, something like that. Okay, so jth wizard on jth person is time I is equal to skill of I into mana of j. Okay, skill of I, mana of j. Okay, so I hope so these skills are like some wizard skill. Okay, assuming that, let's understand better with the examples. So since the brewing process is delicate, a person must pass over the next wizard immediately. Okay, so once this wizard completes its operations, then it will just pass immediately to the next one, then it will pass to the next one immediately. There should not be gaps between them. Okay, got it. This means the timing must be synchronized so that each wizard begins working on a person exactly when it arrives. Okay, so whenever the process arrive, it will start working. It should be free by that. Okay, retain the minimum amount of time required process to be brewed properly. Okay, let me clear drawings first, and we have to find the minimum amount of time required for the portions to be brewed properly. All the portions to be brewed properly, we have, these are skills of these wizards, these are the portion strength, and how much time it will take, skill into mana. Okay, great. So let's see how we can solve this. Something like each skill we have to go, each mana we have to go we can't sort this mana, we can't sort the skills. It will be mostly like n square kind of thing. N into m means of n into m. Okay, so let's see that if our constraints support that. If that's the case, then we will directly look for that solution, otherwise we will be trying to optimize it. Okay, very well. N and m both are like 5 into 10 raised to power 3, so it will be n into m will be 5 into 10 raised to power 3 square is equal to 25. 2.5 into 10 raised to power 7. Okay, it can be accepted in 1 minute, 1 second, because 1 second we can do 10 to the power 8 operations. Okay, great. Then 105 skill of 5 will be maximum of 5000. Okay, so let's go through some examples to understand the problem better and how we can approach it, what solution we can define. Okay, so here we have, let me change color. Here we have skills first of all. So I am naming these skills like wizard skills. Okay, so we have some wizards here with have like 1 5 2 4, 1 5 2 and 4. Then we have mana, and I am assuming that's the potion. So yeah, potion strength is mana, so I am renaming it as a potion for better understanding. Potion says like 5 1 4 2. Great. So output will be 110. So we need 110 time to brew all these potions, all these 5 1 4 2 strength of potions properly. We have to brew each and every one like in sequence, like 5 should be brewed first, then 4, then 2. Okay, something like that. Okay, so let's change the color. Okay. So if I don't see that explanation, let's leave this, and first let's continue doing this. Okay, so if I am doing this potion number 5, okay, if I am doing potion number 5, how much time it will take? I have only, let's say, potion number 5, so it will be like how much time it will take. First one 5 amount of time, 5 25 amount of time, but it will be like plus 25, because after this completion, after t equal to 0, let's say we are starting our operation at t equal to 0, at t equal to 5, the wizard number 1, this wizard number 1 is completed its operation. Okay, so wizard number 2, when it can start its operation at t equal to 5, so when it will complete 5 into 5, 25 time it will take. So it will take previous how much, where we are starting t equal to 5 plus how much time, 25, so it will be 30 seconds, like 30 t equal to 30. So at t equal to 30, it will complete its operation. Okay, so when this will start and complete, this will start at t equal to 30 and it will complete in 10 time. Okay, so at t equal to 40 it will complete, and 5 goes 5 4 is 20, so the fourth wizard will be completing its operation at t equal to 60. Okay, so let me clear some of this and let's clearly write. Okay, we are starting at t equal to 0. First will be 3 30 40 and 60. Okay, these are the times, like value of t time, so I am assuming in seconds. Okay, for sake of simplicity. Okay, so at 60 second this wizard will be free, at 40 second this wizard will be free, at 30 second this wizard will be free, and at 5 second this wizard will be free. So at the 60th time we know that the first portion is completely brewed, done. Okay, so now we can move ahead with first portion. Okay, so to move ahead with first portion, if I take only the first portion and let's brew it only the first portion, let's consider how much time it will take. It will take 1 comma 5 plus 6 comma 2 plus 6 8 comma 4, so 12. So this will be the answer. This will be the array at which each of these wizard will be getting freed if we have only this one person. So now considering that we have one person before this one, and we have already calculated this complete, like when the wizard will be freed brewing this potion, so we can start brewing this potion. Okay, so after completion of this, let's say after completion of this we start this one. Okay, so 60 t equal to 60 we have completed this operation, and t equal to 60 we have started potion number 2. So it will be like 1, so 60 plus 1 61, then plus 5. Okay, so it's 66 to 68, and then 4, which is 72. Okay, so by time 72 this portion portion number 2 will be prepared. Okay, but we, from this example, if you see in the explanation part, this can be optimized. This can be optimized here, because we don't need this 72 seconds of time just to brew these two, because we can, like, this wizard is free at 5, we can start brewing its like second number of potion. By the time it reaches till here, this wizard should be free, so we can pass it on, and then this will be processed. Okay, so just a minute. Okay, for explanation, if you can see, for potion number 0 we are starting at t equal to 0, this is start time. Okay, so first wizard will be done by 5, 30, 40 and 60, exactly which we have calculated, because it's the same for the one portion. But from the second portion, if you see clearly here, we are starting at 52. Why we are starting at 52? Why? We have optimized this time. If we start by 52, is the 52 smaller than 5? This wizard will be free at t equal to 5 seconds, right? We are starting at t equal to, let me change the color. So we are starting at t equal to 52. Okay, so this will be free, correct? So 52 plus 5, it will take 52 plus this 1 cross 1, 53. At the time 53, this wizard will be freed. Okay, for the next one, we are like marking them when they will be free for the next portion to be handled. Okay, then 1 cross 5, 5 plus 53 is 58. So this wizard will be freed by 58, and when we are giving him this portion, we are giving it 53 time, and 53 is less than 30, means this wizard will be free, and we can hand over this portion to this wizard. Okay, portion number 2 to wizard number 2. Okay, now by 58 we have the wizard number 2 have processed this portion, so we can pass it on to third wizard. Okay, and third wizard will be freed by then, yes, because 40, it will be freed by 40, and we are at t equal to 58, so it's completely free here. So at 58 we have passed it to here, it will take 2 seconds, so it will be 60. Okay, at t equal to 60, if you see exactly at t equal to 60, the fourth wizard completed its first brewing of the first portion. So we can hand over to the third wizard this portion, fourth wizard to this portion, and it will be completed by how much time it will take? 1 cross the 4, 64. Okay, so if you see that we are neck to neck here, and we have optimized for the time, and the second portion will be completed by the t equal to 64. So answer will be like t equal to 64 if we have two portions only. Okay, great. So let's go ahead with the third portion, t equal to, at what time it is starting? It is saying we can start at 54. Oh, we can start at 54, and we can build it. Nice. So how much? 4 cross 1, 4 is a, so it will take 4 time. 54 plus 4, 58, it will be completed by 58. Then 4 5 are 20. Okay, so it will be 20 plus 58, 78. Then 4 to the 10, so it will take 80. 4 to the 8, so it will take 86. And then 4 4 are 16, so it will be like 102. Okay, this Okay, if you see here we have optimized this time. So second wizard will be freed at t equal to 58 for position number 2, but to handle the position number 3 we have to start at 54, so we can pass it on at t equal to 58. The first wizard will be done with the third position and this is free, we can pass it on. Okay, this will be free and answer will be like t equal to 102. So we have to optimize this something like this. So we will be thinking of a solution like how we can optimize this time. Otherwise, so if this last wizard completes this operation and then we will start with the next person, then so it will take too much time. Okay, it will be not optimized time, and that time will not be minimum time, right? Okay, great. So let me clear these drawings and let's okay. Let me not clear. Let me change the color of the marker. Okay, how can we make this possible? Like 58, 78, 70. Now we are moving like at t equal to 50, like it's free at 58, but still we are waiting and still we are starting this last portion at t equal to 86, so it can be completed by 70, 88, 98, 102. So we are optimizing here for this column, like this last wizard will be freed by 102 and we will hand over this fourth portion to this fourth wizard and it will be completed by 110. So 110 will be our answer. Okay, in example of why wizard 0 cannot work with first person before t equal to 52, consider the case first person at t equal to 50. If that's the case that we have started at t equal to 50, it will be case here, right? It can be completed with 58 and this wizard is not free, so this person cannot be brewed and this person should not be waiting. That's the condition we have. Okay, wizard 2 done first person, wizard 3 will be start working on the 0th person time at t equal to 60. So same I have explained. Okay. With this standpoint like 1 1 1 1 1 1, output is 5. How they are explaining this, that preparation of 0th person begin at t 0 to 0, t equal to 3 it will start, so it will end at t 1 to 3. Okay, and at t equal to 2 we can start it, so it will be like t equal to 1 we are starting again, so it will be like 2, it will completed by 1, so each multiplication will be like one time. So at t equal to 1 we will start again 2 3 4, and then at t equal to 2 we will start the third portion and it will be completed by 3 4 and 5. So by the time it is free we are handling over this, by the time it is free we are handling over this, something like this, if you see the relation. Okay, so this relation if you see, it's dependent on the previous iterations ka next one. Okay, and it's depend on current iteration ka previous one. Okay, just previous and next one from the previous iteration. Okay, great. Now I see something like this ki if we have calculated this and if we have calculated this, we can calculate this one. Okay, reverse is also true. So if we say that if we calculate, let's take the example of this one. So let's say we have pre-calculated this first one, it's easy one. Okay, the first person is easy, we have filled this array. Okay, now to determine what will be the value of this array, okay, we will start from the first element. We will say that okay, what's the maximum value? Okay, and we will check for this next element that it will be freed by 30 and we can start by, it will be freed by 30. Okay, so we will consider this time. One consideration is this, what time we can start this. We can start at obviously t equal to 6 because t equal to 5. Okay, as minimum is we can, or we can start at 0. For example, we can start it preparation at 0, then it will be freed by 5. So we can't start till this one, first one is free. Okay, so we can't start the first person. Okay, let me explain like something like this. I understood this. Okay, so the first one is 5 comma 30 comma 40 comma 60. We have filled it somehow, like by simple prefix sum multiplication. Okay, so we are going to calculate for the second one. Okay, how we are going to calculate? So let's look at this is completed already. We are at we are going to start the zeroth one, first like second portion. Okay, and for the first wizard we are going it. So we are going and giving this second portion to the first wizard, when we can start and when it will be ended. Okay, when we can start and when it will be ended. So when we can start at 0, obviously at the starting of the event we can start, but obviously this will be freed by 5. So we will take the maximum of 5. So obviously 5, at 5 point we can start. So we will update it to 5. We are starting at 5 and it will be completed by 1 cross 1 6. It will be completed by 6. So we will add that as well, like skill of I multiply by portion of j. Okay, something like that we will multiply, and we have the answer that it will be completed by 6. It will be completed by 6. Okay, now 430, when can we start as the earliest, because it will be completed by 6. So we have to start by 6 plus. Okay, immediately we have to start, right? 6 plus, but this is not free. This wizard is saying I am not free till 30. Okay, so we have to take the maximum of 6 comma 30. Okay, so it will be like 30 obviously. So let me remove this. Okay, so 30 plus then skill of I comma 1 cross 5 to 5. So it will be freed by 35. There is gap now. So we can't hand it over this person to this person immediately after that. So there is some gap now. So we will check that. We will try to reduce this gap somehow. So let me remove some of the drawings. So we have some space here. Okay, got it. So 8:35 it done. This wizard is saying I am not free till 40. It is not free till 40. So obviously it will say that I will be available by 40. Okay, and we are saying that we can hand over this portion to brewing process to this wizard by 35. Okay, so who will win? Obviously this 40. Maximum of both of them we can take 40 plus we will do scale multiplication of I comma portion multiplication of j. Okay, so it will be like 1 cross 2 plus 2, 40 plus 2 42. Okay, great. So 842, this will, if we hand it over somehow it just after 40, it will be completed by 42. Similarly 42 and 60 ka maximum will be like 60, and we will hand it over at 60, so it will be completed by 60. 1 cross 4 64. Okay, so if you actually see, we match this output at least, that this portion is completed by 64. Okay, but we have added some gaps here. So now refill these gaps by backtracking. Okay, so let me show it with same example. So let me clear the drawing first. What we have 6 comma 35 comma we have 6 comma 35 comma 42 comma 64. This kind of thing we have. Okay, for the portion number 2. We have this array which we have calculated with some gaps. But we are sure that this can be handled properly, and this wizard will be like calculated properly. Okay, we are sure about that. Okay, So after doing this, can we fill the gap? Obviously yes, because we can minus this skill cross. So we have skill arrow 1 2 1 5 2 4, and we have a position arrows of 1 5 1 4 2. So this 1 multiplied by 4 will be added to this end time, right? So when this end time is 64, when should we give it to this? We should give it 4 just it will take 4 time, right? 4 unit of time to complete it, so we should give it at 60. Similarly, when should we pass t equal to 60? We are passing to this third wizard. When should we pass to second wizard? When should we pass to second wizard? So it will be completed by second wizard will complete its operation by third wizard will be completed its operation by 2 unit. It will take you 2 units, so we can minus subtract that. At 58, if we pass it to the third wizard, it will be completed by 60. We will pass it to fourth wizard, it will completed by 64. Okay, great. So similarly, if we reduce this 5, so it will become 50. 64 53, yes, 58 minus 5 53. Okay, so we will be like backfilling this data to reduce gap. So now we will have the proper answer that at 53 we will start the operation. After doing this operation, 852 obviously, minus 1 if you do 852, we will start the operation. It will take one time for the first person, 1 cross 1. So 53, then it will take 5 time, 58, then it will take 2 time, then 4 time. So this will be like continuous without any gaps. We can continually pass it to the next wizard. Okay, so I hope you understood this algorithm. This is like not much intuitive, but I hope you understood that how we are juggling it between positions and wizard, and how we are optimizing for the time front. It's something like greedy solution if you see. So let's directly jump into the code and quickly code it. So without taking much time, let's take n equal to skill dot size, then m equal to mana dot size. Okay, so we have to create in this dp matrix. Okay, something like dp, or you can say time matrix. Okay, time of ij, say vector of vector, and we have time, and we will fill this complete time by n size, n comma n size. Okay, it will be like n wizards and m positions, no, m positions. Okay, so n comma vector of int m. Let's take time as 0 for initialization purposes. Okay, so we will be hovering over each portion first, right? J equal to 0, j less than m, j plus plus. So we are having first portions here, then second, then third. So for each portion we will be calculating this wizard wala setup completely. Okay, so for each portion we have taken the portion. Now we will be traversing through the wizard and checking that at what time it will be completed. Okay, so int I equal to 0, I less than n, I plus plus. I prefer to do it like this way, keeping the I pointer as like the first array, which is length n, and keeping the j pointer for the second array, and which is the length m. So it will be like easier for me to code it out and without much overhead. Okay, you can rename these variables obviously to whatever you want. Okay, so let's go ahead, and at t equal to 0 we are starting. So for each one we will be starting with t equal to 0 first, and we will be taking that maximum of both of them. Okay, so int, let's say current time equal to 0, we are starting at 0. We will fill that okay, maximum of what we are going to take. We are going to take maximum of current time, comma previous time, right, times का by what time the wizard of I is free. Okay, so by what time, let me do something. We have a person 0 calculating for person 0, yeah, person 1, person j. Let's say we are calculating for person j, and person j is this, j is equal to 2. Okay, so we will be starting with what time we should start. We should start by 54. Okay, how it will be calculated? By the backtracking one. Okay, so let's forget this. We are starting at 0 time, t equal to 0. We are starting with t equal to 0. Okay, but this one, the wizard of 0 is saying that it will be completed by 53. It will be completed by 53. Okay, so after that we can start, obviously. Okay, so we will say that it will be previous iteration ka. Okay, previous iteration is j minus 1, j minus 1 iteration ka first one, like ith one. This is the time. Okay, it will be get freed, and the current time is this. We will take the maximum of this, plus we will add this our skills. Okay, so we will add our skill of I multiply by skill of j, obviously. Sorry, portions of j, mana of j. Okay, and this can be in a long, so we will like typecast this multiplication in a long manner and long data type, and we will store it. Let's take integer time ended. Here for the person ij, we have calculated at what time it will be end. Okay, and we will fill this time here, time of ij, sorry, jth person for ith wizard. Let's take it something like ij. It will be easy for us to manage it, because we have defined n cross m array rather than m cross n. Okay, so it will be like times of ith for j minus 1. Okay, good. It will be time ended, so we can directly assign this. There is no need to define extra variable here. Okay, so now we have filled this array for I equal to 0, and it will be a disaster, right? No, for j equal to 0 for the first person, it will be like j minus 1 is not defined, right? We will check the base case, okay, after that. So we have calculated the first array. Now we can calculate this like backfilling of this data from the last two first, so we can avoid these gaps which we have talked about. Okay, so we are like traversing once, and we are filling all these details, and then we are traversing back, and then backfilling these gaps. Okay, so at the end moment, if you see at the end, and this 64 or this 102, this will be well calculated. Okay, from there we are backtracking something like this, okay. So for this, let's take our I from n minus 1 last, or n minus 2, okay, because last is completely like correct. I greater than equal to 0, minus, we are going in reverse. For time of I comma j, for the jth person we are calculating everything, and for I comma j will be like time of I plus 1 comma j minus skill into mana जो भी है, minus skill of I plus 1, obviously their skill, and this person, obviously person is this one, so their skill we are removing that, which will be added, obviously. So this way we can say that this is the start time of, okay, 102. If I remove 64, and if we remove this skill of this wizard, then it will be like 60. By this time ij, it will be ended. Okay, great. Then what to do after this completion? We can return time of what the n minus 1, m minus 1. Okay, this last element we have to return just. Okay. I hope this will work. Is there anything we are missing? Nothing, I don't think so. Yes, the base case we are missing. For the portion 0, j minus 1 will not be defined, no? J minus 1 will not be defined, yeah. So let's take care of that. Time of j minus 1, okay. So let's what we can do here, we can do something like, we will calculate this j minus 1 wala, we will start with j equal to 1 here, and we will calculate separately for j equal to 0. So we know that j equal to 0 here, so this algorithm we have to calculate something like this. So I am making it current time. Okay, current time will also be keep updating, right? We have forgot that current time is when this time is ended, right? Okay, so current time will become current time will become time change. Great. Okay, here also we are calculating that first, and then we will be current time equal to times of ij. Okay, here j equal to 0, obviously we are calculating for 0, we are calculating for 0, and we are calculating for 0th portion for each and every skill. So I hope this will work. Let's dry run it once here, that if we have material drawings, okay. So something happened, my bad. For t equal to 0, current time is 0 to n, we are going for ij. Okay, it will be like t0, right? For 0th portion, each add time, like time 0 will be current time, which is 0, time of I comma 0. Just strange, this is like previous iteration, or previous iteration is not there, so it will be like 0, obviously, right? So we don't have to take any max, I don't think so. We are going to take any maximum here. It will be like current time 0 plus long of scale of I multiply by man of 0. So man of 0 is 5, multiply by 1, it will be plus 5. Okay, so time I0 will be like 5, 0 will be 5. Then this will come, this first wizard. So time of first wizard and 0th portion, it will become by current time will become like, we have saved it 5, and current time will become plus 1, then this one. Okay, we don't have to store, I don't think so, current time also. We can do something here I minus 1 wala panda, we can remove this one, and we will start this I equal to 1. Okay, I minus 1, or t, what will the like t time of I minus 1 0 equal to I minus 1 is 0 basically. Okay, so what the time 0 will be, this will be like a scale of 0 comma man of 0. So it will be like scale of 0 comma man of 0, and then we are filling this, then we are doing this algorithm. Let's run this and check. Yeah, all three cases are accepted. Let's submit this. It's saying wrong answer. How many tests? 719 out of 744 accepted. Okay, output is wrong. Okay, we have to define it as a long. We have got the error of integer overflow, I think. So this is 0 long, we are doing here as well. Let's copy this test case, let's run it on this test case now. skill, this is mana, and let's run this first just to check that it will pass here. It is saying that it's a long here as well. My bad. Let's run it. It is saying it will be like mix of this comma this, long skill comma mana j. Okay, and max will not work for current time. Kya? Time of I minus j minus 1. No matching function for call to max. I don't understand that. Let's make it long as well. If that's the case. Both of that long and yeah, yes. Now it's making sense. Let's submit this. Yeah, it's accepted here. We have taken too much of memory, like we haven't bet, we have taken too much time, I think. Okay, I don't think so we can optimize on front of this time complexity part, but I think so that we are doing lots of things here. We can, like, this is like 2D DP kind of setup where we are doing some iterative process, so we can think of eliminating this one dimension of this. Okay, so I hope you understood this solution at least, and exercises that you try to solve it using 1D DP, not like 2D DP which we have solved. Okay, time complexity will remain same, but can we use this same array, like take a array, and can we use these same elements as a like previous index and current index as well? Okay, so that's the homework, you can say. Let's meet tomorrow. I hope you are doing great. Bye.